Hello, IB Math SLAI students. I'm going to do a little bit of preparation for the mock exam. I'm looking at our It's Learning course here. If I look under plans and then under exam revision, and I should have a plan in here for the mock exam, and then I'm looking at mock exam preparation. I have a bunch of files here. Some of them are Word files that could be edited. The format's kind of weird, so I did a couple of, and the mark schemes are also here. I did a couple of PDFs. So I'm going to do paper one first. Here's paper one. We write the answers directly on the paper for paper one. For paper two, we must use separate paper. Okay, the first question, chicken eggs are classified by grade, and then their weights are measured based on their weight, sorry. And the weights are here in the table. Go over to my iPad. First question, state whether it's a continuous or a discrete variable. Well, for 1 point, it's continuous because anything measured is going to be continuous. Write down the modal grade of the eggs. Well, again, the mode is the greatest frequency. So the greatest frequency is here, 45. Okay. And so I wrote down the answer as 6, grade 6 for the answer. Put a box around my answer, make it easy to mark. Okay, use your graphics display calculator to find an estimate for the standard deviation of the eggs. Okay, so standard deviation, remember, is the Greek symbol sigma. So we're going to be trying to find sigma on our T84. So on the T84, what you want to do is put in, because this is a continuous variable, we're going to be putting in the midpoints of each of these grades. So the midpoint is 45 for the first one, 55 for the second one, 65, etc. Okay, so and then I put in the frequencies in list 2, and then I'm going to use one variable statistics to do my calculation. So over here to the calculator, I already put the data in stat, edit, and then in list 1 are those midpoints, and then in list 2 are the frequencies. Then I just like to quit, and then I'm going to go back into stat and calculate one variable statistics. And when I do that, I must add in that I have the frequency list here in list 2. So that's down here in blue, list 2, second 2. And again, I have the calculator do basically finding out all the differences from the mean. Okay, so I get an answer here of 8.97 grams. All right, then I could say that I used the TI-84 and list 1 was midpoints and list 2 was freaks, and then I did one variable stat. That's my my workings. Okay, next question. The mean weight of the eggs is 64.9. Correct the 3 significant figures. Use your table. And your answer, oh, actually over here you can see on the calculator that it is actually 64.9 for the mean X bar. Okay, find the smallest possible number of eggs within one standard deviation. So again, I'm doing 64.9 plus or minus 8.97, so about 9, about 65, so somewhere between 56 plus 9, 65 plus 9, 74. Somewhere in this range, we want to find the smallest, the smallest possible number of eggs. Okay, so the smallest possible number of eggs basically looks like it's going to be right there in the middle, 45. Okay, that way they're all included within that one standard deviation. Some of these might be outside, some of these might be outside, but these are all inside one standard deviation. Okay, so the answer is 45. We can write the units if we wish. Eggs. Okay, question 2. A snack has a snack container is a cylinder with a base and a height. Did the cylinder come out on my sketch? Okay, there's a sketch of the cylinder right there. 7, they want to find out the radius. We know that the diameter is 2 radii, so we just have to do half of the diameter. So 7.84 divided by 2 is 3.92 centimeters is the radius. Okay, calculate the area of the base. Well, the base is a circle down here. So area of a circle, again, it's on our formula booklet, but we know the area of a circle is pi r squared. Okay, and when we do that calculation on our calculator, use the pi key. So pi here times r squared, which is 3.92 squared. Okay, and then we get our area is 48, rounded to 3 significant figures, 48.3 square centimeters. Okay, and then next they want to know basically the total surface area on this cylinder. So we're going to add the curved surface together with the base of the snack container. Okay, well the curved surface, basically you've done this if you cut a cylinder down the side and then roll it out, you know that it rolls out to be a rectangle, and the rectangle is going to be a base of 2 pi 2 pi r, okay, the circumference of the circle, and the height is going to be the height of the cylinder. So those are going to be our dimensions. So we're going to do 2 pi r times h, and remember that h was 23, I think. So 2 pi 3.92 23, and when I do that on my calculator, I get a value of oh, I have to add the bottom. Don't forget to add the bottom. So add pi times 3.92 squared, because again it's the curved surface plus the circle on the bottom, and when I did all that calculation, I got about 625 centimeters squared that has to be painted. Okay, pizza company here is delivering cheese pizzas. My formula didn't come out on my file here, so let's see if I go back to question 3. Okay, question 3. There's the formula. 3.45, 34.50 n plus 850. Okay, state in the number of the question what 3450 means. Well, 3450 is the rate. So the rate is basically how much each pizza costs. Okay, and then they're going to ask us what the 850 means. This is a fixed cost. It's a delivery company, so I think that's probably the delivery cost. And then the last question is what is the minimum number of pizzas here? And it's indicated n has got to be greater than or equal to 2, and the z means that n is an integer, of course, because it's a count of how many pizzas there are. Okay, so n number, is stating what the value of 3450 means is the cost of a pizza, basically, or the rate. Then this is delivery, and then the minimum was 2. And now we're going to be given a little question where we're going to have to do some algebra, find the maximum number of pizzas. How much money does Kaylani have? Okay, so Kaylani has 450 PGK, and that's what we're going to have to solve the equation. 450 is going to be equal to our delivery, or rate plus delivery cost here. So we can solve this using algebra. We could also solve it graphically on our calculator. There's a solver on our calculator, but for me, I think it's just easier to solve it with algebra rather than using the calculator. So this is my equation. I'm going to subtract the delivery cost. And then I'm going to divide by 34.50, and then I get n. Okay, and again, I'm going to have, I could have a decimal answer, but I rounded my answer to whole pizzas, and I got an answer of 12 pizzas. Okay, Mr. Calhoun is going to be measuring the height of Ms. Calhoun is going to be measuring the heights of her students in her mathematics class. She's interested to see the mean height of the males is different than, or the same, rather, is the same as the mean height of the female students. Okay, so this is again a statistics question. We're going to be using a t-test. Again, text is missing here. We're going to be using a t-test to compare the means of the two groups. Okay, so again, we could calculate the means and see if they're the same, but again, the t-test is going to do this statistically and look at each individual value. Okay, so state the null hypothesis. The null hypothesis means basically that the heights are the same. Okay, because again, she wants to see if they're different. If they're not different, they're the same. So the null hypothesis, again, I could write in Greek, I could write M1 is equal to mu2, mu2. That would be my null hypothesis. I think in the answer scheme, they said that the difference is 0, so they subtracted m2 mu2 minus mu1, okay, and said that's equal to 0. Okay, so the alternate alternative hypothesis is basically the opposite of this. So I would just say that the means are not equal. And one reason I write it this way and not the way it is on the answer scheme is because that's what we're gonna do on our calculator when we do the calculations. Okay, so again, go into the calculator here, calculate the p-value. Again, text is missing here. The p-value for this test. So again, list 1 is going to be the male heights. List 2 is going to be the female heights. Not that it matters. And then we're going to do a t-test on the calculator. All right, so here's the calculator. Going to go to stat again, edit. I cleared my lists by going up to the top here, hitting clear and then enter. And then I entered in the heights of the males and the females in Ms. Calhoun's class. All right, and then we're going to be asked to do a test on this. Okay, so a t-test is going to be found stat tests, and then this is a 2-sample t-test. Okay, and we have data. We don't have the statistics, the mean and standard deviation, so we put all that data in list 1 and list 2. Are we going to pool it? I'm sorry, let's go back up here. What is the alternative hypothesis? Well, again, I wrote that mu1 is not equal to mu2. Okay, that is the alternative hypothesis. The pooled, we have to do yes every time, and then we're going to come down and calculate our p-value, and we get 0.296 for the p-value. Okay, and then they show the degrees of freedom and the means for the male and female's height. So you can see that actually looks like the males are a little bit shorter than the females. Well, look at the negative 1.8 up here, 1.08 for the t statistic. Okay, so p is 0.296, I think is what we said. And then state whether she should accept the null hypothesis or fail to basically reject the null hypothesis is what the text that's used on the mark scheme. So if we have a high p-value, that usually means accept the null hypothesis. This is a high value. It's almost 30%. And again, recall from our question here that we were doing a 10% level of significance here. So we're comparing all our values to 0.1. Okay, so we want to give a reason. Our reason is that 0.296 is greater than 0.1, or that p is greater than alpha, or that the p-value is greater than the significance level. So this means accept. So there is no significant difference, statistically speaking, between the males and females. Question 5. Professor Vinculum is investigating the migration season of the bulbul bird from their natural wetlands. Okay, so we have a function here that didn't come out again on my iPad. This is an exponential decay function. Basically, it goes down to the right. And we're going to find where t is the number of days since the start, must be greater than or equal to 0. Find the population at the start of the migration season. So t is equal to 0 at the start of the migration system. Anything to the 0 power is 1, except for 0, which we can't have as a base. So this is going to be 1 times 400 plus 1350. Again, I could use my calculator for that, but I know that it's just going to be 1750 is going to be the answer. P of 0 is going to be equal to 1350 plus 400 to the 0. So again, that's just 1. And I get 1750 bulbul birds at the beginning of the migration season. Okay, find the population after how many days? 5 days. Okay, so again, I'm going to be looking at what's happening to this population, and I'm going to use my T84 for the model. I'm going to put it in y here, and you can see I put in the equation for the function. And again, make sure that you use the negative sign on the x here, and that I use the x from here. And I can look at the table and get some values off of that. Might be easy. Look, there's our initial population, 1750. At 5 days, I get 1481.1. So you could put 1480. 1480 is 3 significant figures. So P of 5 1350 plus our exponential to the negative 5, and you get about 1480 birds. Okay, calculate the time taken for the population to decrease below 1400. So I like to solve this graphically. We're going to be studying a little bit of logarithms, but not really using it for solving equations, exponential equations. So I'm going to put in y1, I have my function, and then in y2, I'm going to put in 1400, and then basically I'm going to look at where the exponential decay goes below this 1400 line. Okay, looking for that point of intersection. So go back here, put in 1400. Started at 1750, huh? And it's coming down to 1400. So if I look at my graph, maybe it's not showing. I might have to do a zoom fit or a zoom stat or mess with the window. I need to go up to 2000. I see my exponential decay, and I see a horizontal line. Oh, okay, there it is. So somewhere in this vicinity is the intersection, and the way to do that is go second, calc, intersect, and then I just hit enter 3 times. 1, 2, 3. Okay, if I had more than one, I would have to look around there and see that. So I get 9.32 days for T, approximately. Because they're leaving all the time. I'm not going to round this to an integer or whole number. Okay, according to the model, find the smallest possible population of birds during the migration season. Well, I don't know how long the migration season is, but basically I'm looking for a horizontal asymptote for this exponential decay function. So it's flattening out as it goes to the right. As we see with our graph here, I could go trace and take a look at it. I think I'm on the blue function. Yeah, I am. And you can see it's going down, 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 down. Well, maybe the table might be faster to see what it is. Or I could do it analytically, that the exponential part of the function is actually getting smaller and smaller and smaller and smaller and smaller. Okay, so this part here of the function is basically going to 0. So you can see that we're getting closer and closer to a value of 1350. Again, the table is another way of doing this, but it's a little bit clumsy to go, way out in time on the table. So the answer is 1350 for the horizontal asymptote. Got lost here. So T is very large. 1350. Okay, next question. Mia baked a large apple pie to give to her friends. So it's a very flat cylinder, and it's given some missing data here on my file. Okay, so we're given a sequence here. The second smallest slice, the fifth smallest slice. So these are a geometric sequence. So what I did is just kind of map this out to give myself a picture of it. And then I calculated the common ratio, which is asked for in the question here. So the first term, we don't know. The second term is 30, and then the fifth is 240. Okay, so the smallest, it goes from small to big. So each time it's going to be multiplied by the ratio of the sequence r. So we don't know the first one. The second one is 30. Third, fourth, fifth is, what do we say, 240? Yeah, 240. So each time it's being multiplied by r. So r5 over r2 is going to be equal to 240 divided by 30. That's equal to 8. How many times do we multiply by r to get from 2 to 5? 3 times. So what is the cube root of 8? Well, we know that is 2. Again, we could use our calculator for that, but we should know our cubes. Okay, slice what? Sorry, I lost the question here. Oh, we found the common ratio. What is the volume of the smallest slice of pie? So how many were they in our class? Oh, it's the first term in the sequence. Okay, it goes from small to big. So again, we take the second term and divide it by 2, and the smallest slice of pie, I didn't write this one down correctly, is actually 15 centimeters cubed. Or we could, of course, use this is the way I did it actually on my answer paper. They're asking you what is the first term of the sequence. So again, the first term of the sequence times r to the n is equal. That's how we find each term of the sequence, and we could have found it, or we could just divide by 2. And the smallest slice is 15 centimeters cubed. Now we're going to be given the challenge of finding the total of all the volume of these slices. Okay, so again, 61,425 is going to be equal to our sequence total, which is a series. Okay, so in the formula booklet, we want to look at topic 1. These are higher levels, sorry. Topic 1, sequence and series. We want to be using the sum of n terms of a finite geometric sequence, okay, that we have a certain number of slices that we have for the class. So there it is, the formula. We're going to be applying that formula and solving it. So the total is 61,425. And then we put in our formula. 15 is the first slice because that's U1 here. And then our ratio is 2. We subtract 2 to the n minus 1 over 2 minus 1, which is just 1. Okay, so we're going to solve that equation that looks like this. Okay, so this is just 1. Don't need to pay much attention to that. Let's divide this by 15. And so then I'm going to have I'm going to have a 61, 425 minus, divided by 15. And then I'm going to subtract or add to that actually 1, it looks like. And I'm going to solve that is equal to 2 to the n. So what power of 2 is going to be that? All right, so let's do calculate 61, 425 divided by 15. Then I said we're going to add 1 to this, and I see something familiar. This is a power of 2. This is a power of 2, and I think it's 2 to the 12th power. Yes. Okay, so that's 12 slices is going to be the total number of slices for the students. And again, I could have divided this by 2 just a whole bunch of times to figure it out. We're not, again, we could solve it graphically. We put in, sorry, lost my calculator there. We put in 2 to the n, and we set it equal to 4096. All right, so that's what I did here. I put 2 to the x, 4096. Look at the graph. Where do they intersect? Again, I think it's going to be off our graph. I can see it taken off there. 4096. Yeah, my calculator is really lagging here. 5,000 for a max. And I should see the 2 to the n function, and I should see a horizontal line, and then I see where those two intersect. Same procedure as we did before. We should be able to solve any equation graphically using the TI-84. 3 times enter. And I get 12 days. Okay. All right, next question. We got a triangular field, 85 meters on one side, 110 on the other. The angle between the two sides is 55. Find the area of the field. Okay, so again, this is a trigonometry question. We got the formula booklet here. We're going to be looking at topic 3. And in topic 3, we should have the area rule, the cosine rule, and the sine rule. So here's the area rule, 1/2 AB sine C. Again, A, B, C are rather arbitrary here. The capital is an angle. The smaller ones are the lengths of each side of the triangle. So we need to draw the triangle and make our calculations on that basis. Not sure what the angles are. I only know this one angle here. What was it, 85 by 110. And then this angle was, these are meters, and this angle was 55. So this is SAS, side angle side, for the area rule. We just do 1/2 110 times 85 times the sine of 55, which helps, again, the hypotenuse gives us the height of the triangle. And when I did that calculation, rounded it to 3 significant figures, got to show you that because we want to make sure that your calculator is set to degrees, that after you got it back from the invigilators that you put on degrees, and that stat diagnostics is on there on the mode. Okay, so when I did that, I got an area of approximately 3830, 3,830 meters squared. Okay, same triangular field. The farmer would like to divide the field into 2 equal parts by constructing a straight line from point A to the opposite side. Okay, so again, I'm missing a lot of the question here just because of the way the file came out. So ABC, and then he's going to come across here with a new line, and that's going to divide the area in 2. Okay, so fully justify any assumptions you make. Well, I guess it says straight France, so I don't really see any assumptions that I might make. There's a couple ways of doing this. We could use the cosine rule and figure out the length of side AC here, and basically split that in half to get our answer, because we want to find the distance AD here. I've got to label that point D. Okay, so this is the question, what is that distance there? So that was one way of doing it. The other way of doing it, again, is we're splitting the area in 2. Again, if I look at side angle side up here, I could use the area rule for that. So if I could find the angle at B, I think that's the easiest way for me to do this, is find the angle at B. So I'm going to use the sine rule because, again, I know some opposite sides and angles. I know this length down here is 110. So if I want to find the opposite angle, and I know this angle is 55, and I need to find that opposite length, don't I? Okay. I need to find that opposite length by using the cosine rule. So go back into the cosine rule and tell me what the angle BC is. Cosine rule here. So BC squared is going to be equal to, again, those two sides were 85 and 110. So 85 squared plus 110 squared minus 2 times 85 times 110 times the cosine this time of 55 degrees. Okay, and so when I take the square root of all that stuff there, all right, here's my calculation. You take the sum of the squares here, but we have to make a correction because it's not a right triangle here. And I got 92, about 92.7 for that side. Okay. So this opposite side here is 92.7. This one was 85. And this angle was 55 degrees. So now I can use the sine rule if I have some room up here. So I did sine of B, the angle B, divided by the opposite length from that, which was 110, is equal to the sine of 55. It just calculated the opposite length as 92.7 approximately. I can use the exact one there. And then I'm going to solve this equation by taking the inverse sine of 110 sine 55 divided by 92.7. Okay, just wanted to show you that I grabbed my precise answer up here. I didn't use 92.7. I used something more accurate. And I took the inverse sine, and I get 76.3 degrees approximately. All right, so we know the angle at the top of the triangle is 76.3 degrees. We're not done yet, though, because, again, we got to find that distance BD there. So I have 85, the angle, and, again, half of the area. So that's what I'm going to be trying to figure out, basically what the distance is here, BD. So maybe I'll add another sheet here, 76.3 degrees. All right, so the sine rule from the formula booklet we know is this way. I like to flip it upside down because we're going to, no, we're not. We're going to use the area rule, sorry. The area rule here. So the area is half of the area, which before we determined to be 3830. So 3830 divided by 2 is going to be equal to 1/2 times 85 times BD times the sine of that new angle at the top, angle B, is 76.3 degrees. Okay, so when I solve that equation, I got a value of 46.4 meters, which is actually like I said before, just half of that opposite side that we had calculated here, BD 92.7, 46.3. Again, half of that, the length of that side. So that's your answer to question 7C, or is it B? B, 7B. Okay, question 8. We're going to be doing some probability here. We have a fair dice and looks like a fair spinner. And we're given, they actually did it for us. They did a sample space diagram here. Okay, so 2 dimensions, the 4 sides of the spinner and the 6 sides of the dice. The question is, what is greater than blank 4? Okay, so again, greater than 4 is what we want to find. Again, the sum of the 2 scores has to be greater than 4. We go back to the probability diagram. Anything down here, I guess, all of these possibilities give a score of greater than 4 or 5 or more. Okay, so I count those up and I get 18. 18 out of 24. So that's 3 over 4 or 75%. All of those answers are acceptable and equivalent. Okay, so that's a probability of the outcome being greater than or equal to 5 or greater than 4. Find the probability that Sung-Won scores greater than 4 on both of her first 2 turns. So again, this is independent variables. We need to have an and. So and means multiply. So all we have to do is 3/4 times 3/4 because it doesn't change. It's not dependent. It's independent. So I get 9 over 16 for that answer. All right, Sung-Won will play the game for 11 turns. Sorry, missing that question. Find the expected number of times that the score is greater than 4. Here it is. So all I have to do is take, again, 3/4, the p-value, times the total number of terms, and I get 33 over 4, or again, 8.25, I guess you could say. Just reading that is, yeah, it's greater than 4. Okay. Now we're going to do bird bath time. So again, we have the shape of this bird bath in a cone on top of the pedestal. It's the interior of the bird bath that we're worried about. And I see a right triangle here. Write down an equation in R and H. Okay, missing that information again on my file here, but it's on the original R and H. So again, it's just going to be Pythagoras, R squared plus H squared. equals to the constant slant height I thought was in our diagram. $50 squared. Okay, so that is our Pythagoras. So we're going to be asked to find the volume of the bird bath, or show that the volume of the bird bath is the equation that they gave us, which is, again, in terms of R only. Okay, so I need to solve this equation up here for R and get the square root of 2,500, 50 squared, minus h squared. Sorry, we want to find the equation in terms of h, actually. Okay, so v of h is supposed to be equal, let me look at the original questions here. Oh, there it was. I missed it. Okay, so v of h is supposed to be 2,500 pi h minus that. Okay, so again, they solved and got rid of the r in the equation. So the equation was for the volume of a cone. Okay, so the volume of the cone is basically 1/3 the volume of a cylinder. So that's actually in this equation right here. V, let me go back. V is equal to 1/3 pi r squared h. Okay. I think I forgot to square root it there. Okay, I forgot to square root the R value. Okay, so just take that and do a little bit of substitution here, and V in terms of H only now is going to be 1/3 pi. Take that thing, square it, and multiply it times H. Okay, so when we square a square root, we get what's underneath the root. So 1/3 pi times 2,500 minus h squared times h. And again, when I expand and simplify this, I'll get the equation that they wanted. I could show more workings, but I think we see that it is 2,500 pi h over 3 minus pi h squared divided by 3. Okay, so 9c, they want us to find the derivative in terms of h. So that's why we had to rewrite that equation in terms of one variable only, so that I can find the derivative, because we don't know how to find the derivative of more than one variable. Okay, so I'm just going to apply the power rule to our original equation here. And the power rule, we remember in calculus, differential calculus, topic 5, is just take the power down front and then multiply it, and then subtract 1 from the power, and we get the derivative, dv dh in this case. So there's v as a function of h. And then dv dh. We're going to take the power down front. So I see that this has a power of 1, actually. So I take that down front, and then I get h to the 0, and I get just the coefficient out front, which is equal to 2500 pi divided by 3. Okay, so that's the derivative of the first term. The derivative of the second term, take the 2 down front. Ooh, that looks like a 2. And then that's going to be pi h divided by 3. So there is dv dh right there. And then we're going to be asked to do some optimization. So optimization, we're going to just be setting that derivative equal to 0. Maximum volume. So set the derivative equal to 0 and do a little bit of algebra and solve for h. So we're going to be taking, 2500 it was just pi, that's right. Got rid of the h. 2500 pi divided by 3 minus, whoops, it was 3 over 3. This was cubed here. Sorry for that little mistake, because again, we had an h times an h. Okay, so 3 times 3, it's just going to be, 3 over 3 is just going to be 1, so it's actually minus pi h. A little mistake there. Pi h squared. Okay, so solve this equation, and we're going to have h is going to be equal to the square root of 2500 pi. Whoops, the pi's cancel out on both sides. Okay, we divide both sides by pi, and we get rid of that. So just what is the square root of 2500 divided by 3? And that is approximately equal to, I didn't write down the answer here. I used the exact answer because they want to find the volume of the bird bath. So I could use that exact answer to find the volume of the bird bath. Again, I'm ignoring the negative square root because this is measurement. It's length. So I'm not going to have. Okay, so substitute this into the original equation for volume up top here. Okay. So when I substitute that into the equation, I get 2500. Sorry. Yeah, 2500 v as a function of h. So what is v for the square root of 2500 divided by 3? So it was 2500 pi divided by 3 times the square root of 2500 divided by 3, simply, minus pi over 3 times the radius cubed. Radius is 2500 divided by 3, square root, and then cube that. Okay, so when I did that calculation, I didn't write it down. We can check it on the answer sheet, but you'll see what you get. Okay, next question. And this is the last question. So we're asked to find the value of R using this trigonometric formula, and we want to find it correct to 3 decimal places. So this is just a calculator question. Can you use your calculator correctly to find that value? And again, I like to use the fraction trick myself. You can use something else to get to this kind of format, or put brackets. Put brackets. I didn't like that. Put brackets around your denominator. So 1 divided by the sine of 86 degrees minus the sine of 85 degrees. So just make sure that you can round to 3 significant figures. And I got 730, and then we're going to be asked to compare it to rounding both of the signs to 3 significant figures before taking the difference, and then you're going to be found the percentage error in the calculation. I'm skipping all this stuff because it's just basic calculator use. It will be on your mock though, so be able to find error by using the error formula, which is under topic 1 right here. Okay, and again, the absolute value, just make sure that the error is positive. You don't have to use the absolute value function. So you're going to make some approximations and then find out the difference from the exact value. And that concludes paper 1. You can check the mark scheme on its learning. Here it is, the mark scheme.